Develop your skills. Exercise 3, Development 04. Use the PMT and FV functions. This is a great test of a real-life application of Excel. This is more than just an exercise in the book. This is us really getting a good feel for if we take out a loan for X, how much will we pay in the future? X plus Y. Well, what's Y? Let's find out. This is helping us figure out what it's going to cost in the long run. If I invest in this now and it's going to make me this amount of money, will I profit in 5 years? How much will it cost me to get this now versus wait in 5 years with a loan taken out? Let's find out more. Open up your workbook from the previous exercise and click Fundraising up here at the top, or just open the Fundraising book. Click on the Loan tab down here in the lower left if need be, and then what we're going to do is we're going to enter in the details of the loan. First, we know we're going to need $700,000 to get this business off the ground. Buy the land, build the building. Don't need anything huge, but that's what it's going to cost. We got $100,000 to put down. We're going to need the total cost minus what we have as a loan. So let's enter it that way. It's pretty easy to eyeball this as $600,000, but remember, it's always best to let Excel do as much of the math for you as possible, and we'll go over why here in just a moment. Whenever you have something like a total loan amount, you're going to want to enter this instead of just 600,000, because not only will it give you 600,000, but if we find out, hey, we only need 650,000 instead, the math updates automatically. We don't have to worry about finding another cell and having a typo in there, or worse, forgetting to update some of our math down the line. Have Excel do as much of this for you as possible. When it comes to interest rate, there's no math for that. We just get that from the bank. They tell us what they think they can get out of us, and we tell them if it's acceptable. In this case, it's 6%. When I type 6, it puts the percent right there, so we're good to go. Remember, the difference between 6% and 6 is 100 times. 6 is 600%. 6% is 0.06. You will know when this $600,000 loan charges you billions of dollars, but yeah, let's just make sure that we've got percentage in there. It'll remind you when you're done with the math. We have the total amount we need. We have the interest rate. Let's find out what these payments are going to be here. 5-year loan, 12 months and a year. And now we go to the PMT function. It's not a huge deal, but put a negative sign in front of this. PMT deals with payments. Typically, it's used for what's being paid out, which means that if we were the bank and asking, what are they going to be paying us, we would be looking at their funds as reducing. Since we're looking at our funds, we want to know a positive number. What is the number that we will be paying? It's not a huge deal. It just deals with a minus sign in front of this when we're done. But if you're wondering why they have negative PMT there, it's because PMT returns a negative value by default. Remember, multiplying by -1 just turns the number positive. We can enter this manually, entering the rate of the loan as B7, which is the interest rate divided by 12, which is the number of months. It's the annual interest rate divided by 12 gives us the monthly interest rate. Then when we hit comma, it moves over to NPER. You'll notice that the bold is no longer on rate, it's on NPER, the number of payments. I will ask you to skip this way for now. This is more useful later on when you have embedded functions and more complicated things that are, a function and a function and a function. Click the insert function box and work with this guy in the function arguments. It'll make things a little easier, especially since you get these reminders down here and you get a formula result as you're going, so you know if it's going to kick back an error even before you're done, and you can resolve that error. Moving along, NPER, number of total payments. It's pretty straightforward. 60 payments once per month. And the present value of the loan, that's also pretty straightforward. That's just $600,000. When we click OK, we have $11,599.68. Good stuff. We know what it'll cost each month to take out $600,000 to get this business started. Let's do a little bit more here. Let's make sure that our loan payments are properly in accounting format. We either right-click and click Format Cells here, or just as long as we have this cell clicked on, we can click the dialog box launcher right here, that little kind of like downward right pointing arrow next to number, and it'll also bring up Format Cells. Click Accounting. 2 decimal places is the default. Click OK. In this case, all I did was kind of move the $sign over, so not a huge deal. But let's try to keep things proper and keep the payments in accounting format. Then we're going to want a little bit more information here. Let's come down to cell B14, total loan payments. That's actually pretty straightforward. The total in loan payments will be what we pay times the number of times we pay it. Don't let a big, huge sheet like this scare you. Just look at the total loan payments are going to be $695, $980, $86. Pretty straightforward stuff when you consider where the number's coming from. If it doesn't make sense right away, remember, try to outsmart the formula. Even before you enter the numbers in as the book asks, try to ask, what is this going to get me? And do I understand where the numbers are coming from? You'll pick it up a little bit faster if you see where this is all going. Now that we have the total loan payments, we can calculate the total interest by simply taking what we're getting, or by taking in total what we'll pay from what we're actually getting, because the total interest is going to be what we had from what we paid. The difference in what we paid versus what we got will be the total interest we pay, $95,980. It's creeping up on 6 figures of free money that they get from us just for loaning us money. If this project is going to make us money, it's going to have to make us more than that in 5 years. Now, we've gone through a lot of the odds and ends here. So let's just put our total fixed costs here, our total financed costs, which is just going to be the grand total of this whole deal. What we have, what we will pay initially versus what we will pay by the end. We're going to need just shy $800,000 to kick this business off. If we give $100 now, borrow $600, and pay back in 5 years. Individually, nothing we've done here has been too tough, but it can be pretty easy to get lost in this ocean of numbers. Remember, if this isn't making sense, put it down, forget about it for 24 hours, come back the next day. Usually the best way to do it. Now, we also have the FV function, future, the future value here, and the FV function considers what if we have a couple of invested contributions, things that are going to bring us some interest back, or things that if we ask others to invest in, what will they get out of it in the end? This is looking at the future value of an investment that we're going to make. Let's do this. Let's take this very first portion up here, and what we're going to add in is just the basics. No initial contribution means a starting balance of 0. Interest rate, 2.5. We still got the percent on there, so we're good to go. And the number of months, 3 years. Remember, there's no real formula for 0 or the interest rate or the number of months. Those are just things that we would decide on. We're asking, at this rate for this long, what am I going to get? The number that we're getting is where the math comes in. We do have to have a few constants in here. Now, our monthly contribution is where things are going to start to use the math. The monthly contribution will be the total amount divided by the number of payments. You seeing where it's coming from? Monthly, with this many months and this month's amount, we're going to want 1/36 of 300,000 per month. There we go. Let Excel do that part for us. Now the total investment, here's where FV comes in. Your book has you grab this one via the insert function box, so let's try that way. Once we click here, once we've clicked on the cell that we're going to enter the function into, we click insert function, and when we haven't clicked equals or anything yet, it'll put an equal sign in and then say, let me know which function you want. We can either go to financial, or we can just start typing FV in the search box. What do you know? FV is the first thing that shows up under FV. Logical. There we go. Now with the function arguments box up, remember this is the best way to enter functions when you're only using one in most cases. We're just going to enter in some basic numbers here. We've got B7, which is our interest rate, but remember we're doing this monthly. B7 divided by the number of months in a year gives us an interest rate of 0.208% there. Coming down to the number of payments, well, that's pretty straightforward. 36 months, 1 payment per month, 36 payments. PMT itself, don't let this one throw you off. This is another one of those kind of nitpicky things. They have you enter a negative and then select B6. A negative means that the payments, since we're paying this out, we would be getting paid negative $8,333.33. It isn't a big deal. If you forget to put that in there, it'll turn it red, but it's the exact same number. If you get that big, uh-oh, wait, what? Our investment is returning negative more than we invested? Oh, silly me. I just need a negative on payment. There we go. Some people can worry about that negative sign in the front. It gives you the correct value in the end. It's important that you have it there, but it's also really easy to see and fix. Let's do one more. What if we have this initial 25% contribution? Again, pretty straightforward. We've got E3 right here, but it's a 25% contribution at first, so we're going to multiply by 0.25. You can also type 25%. Be sure you have the percent sign, because 25 is 2,500%. Then, pretty easy, we can take range B6 through B9, and we can actually just copy and paste. Now, wait a minute, all my numbers are the exact same. Why is that? Here's why. Once we paste those in, we select cell E6, and what we're going to want to enter in the formula bar, instead of E3, because E3 is just our total amount, we want E3 minus E5. Now, ask yourself real quick, what am I doing here? Where am I going? E3, the total amount, if we make an initial contribution of 75,000, that means that we're looking for the difference. 75,000 from E5, that's the monthly interest we're going to pay, because we've already gotten 75,000 out of the way from our initial 300,000. Remember, sometimes you're not going to work with numbers a lot in your daily work. When we got out of high school, a lot of us don't spend a ton of time doing number crunching. Let this come back to you naturally, and don't get frustrated if it doesn't. Now that we have this one entered in here, hey, right on, those numbers are starting to look a little bit better. Remember up here, we needed E3 minus E5 in parentheses, because division happens before subtraction in the order of operations for math. Chances are you would know if this initial contribution showed up, something is obviously wrong. There's no way we're going to make 11.1 million on that one. Usually those little teeny tiny things that you're thinking, how am I going to ever remember this, are abundantly clear. So don't worry. Just put those parentheses in when you hit enter. That's looking a little bit more reasonable. Now all we really have to do is just make absolutely sure that in cell E9, we open up the function bar. We're calculating the last little bit of this properly. PV, the present value here, negative E5. Since we have a present value, we have to add that to our total investment. And in this case, they also want you to add type 1. As far as what type is the value representing the timing of the payment. Payment at the beginning of the period, i.e. at the beginning of the month will be 1. Payment at the end is 0. If you are paying back a long-term loan and you pay at the end of the month, remember that interest accumulates over time. It may be the same percentage, but if it's accumulated at the very moment it can be versus just once at the end of the month, you end up paying a tiny bit more. Most of the time, you're not going to worry about type. They have you enter 1, but the book doesn't do a good job of explaining it. Yet another reason I like that functions window, it gives you more info. Now, when we click OK, things get a little bit more reasonable. There's an initial balance of 75,000. It does, over time, that little tiny 2.5%, turn into $3,500 more. Good stuff, huh? The difference between these two, over this many months, with this amount of an initial difference, even with the same amount, this is the real power of Excel. Looking at all these different odds and ends and making sure, hey, I've got a good idea where my money's going, and even the little 2.5% can be big money a few years down the road.